how we persist objects locally by getting rid of this whole persistence manager thing we've had for a while, instead using a setup called core data. So core data is going to simulate having a database that's native to iOS. You can add a database under this core data thing, but core data itself is not a database. I know this sounds weird, but when we look at core data in just a second, you're going to see this is actually a really simple system that sets up our persistence for us and sets up the models for that persistence. So we, using this system, are not going to have to even write like a class called, I don't know, dogs, which has these properties. Instead, we do all that through a visual interface that core data creates for us. My goal is today that we just make a simple app that has posts and comments in it. We'll make that from scratch. And then tomorrow we'll see how we can do similar filtering to what we're doing in Firestore with core data, and maybe even build an app that has online and offline support. So using Firestore and using core data. So today, let me show you how easy it is to get off of the ground with core data. First thing we need to think about is, before we create this new project, let's look at my models in Firebase, in this Firebase project. I've got an app user, I've got a post and a comment. If I wanted to save those things locally using persistence, what was the problem? What was the difficulty I might have had? Think about like the creation process for posts and comments on this Reddit app we've been creating. If I wanted to use the persistence helper that we created to save this stuff inplists, there's a lot of redundancy. Because if I want to persist a comment, I persist my comments to some file somewhere called maybe comments.plist. But then if I want to persist posts, I'm probably going to have to persist the comments for that, or make some like really annoying thing where every time I load a post and I want to load its comments, I have to load all the comments and then filter out only for those comments that have the identifier for that post. So there's going to be a lot of like just dealing with arrays, because our persistence manager so far just saved objects in an array to a certain file, encoded and decoded using a plist encoder and decoder on some codable object, and that was a pain. But luckily, just like Firebase has built in all this online support, there's offline persistent stuff in this core data that makes us not have to create a codable object, then add it to an array or remove it from an array or get a whole array, but instead we can just be referencing specific objects. So posts and comments can exist solely as themselves in this core data setup. And then I can just go and find those individual objects. Let me show you how we make core data in our app. I'm going to make a new app because this one's pretty big. I don't think we want to work with it right now. Single view app, add core data. I'll title this project Core Data Intro. That's it. That's all core data is. So in order to add this to my project, I check off this box just like I did with unit tests. It's easy enough. Hit create. Use core data, because this core data intro app is going to use core data. Okay, let's pull this guy down. One thing changed. I've got this thing called core data intro.xc data model ID. What is that thing? Well, we're going to find out. But let's see the changes that this made to the default setup of my app. In my app delegate, what it did was it added these two variables. So it added something called a persistent container. Did this automatically. It's a persistent container for the application. This creates and returns a container having loaded the store, for the application to it. This property is optional since there are legitimate error conditions that could cause the creation of the store to fail. Okay, what is that? Well, let's find out. There's something called a persistence container. It's a container that encapsulates the core data stack in your app. What is all this? Well, so much of this stuff, just like with Firebase, is going to be happening behind the scenes. But basically, the way core data is set up is you're going to have three main aspects that this container creates for you. And those three main aspects have pretty logical purposes. So first, there's going to be built in something that you don't have to worry about naming. You don't have to create something called like posts.coredata or something like that. There's no file called that. Instead, there's just some place called the persistent store. So wherever that's saved in your apps bundle, there is a persistent store. This is just where stuff is saved. Then there's something called a managed object context. And this is where your app actually interacts with some information that has been loaded from what's stored. It sounds weird, but we are not looking at the store in our managed object context. Instead, we kind of have a controller here, the persistent store coordinator. Looks kind of like MVC, because here's where the stuff is saved, here's the thing that can retrieve it from being saved, and here's the place where you can use it. So the managed object context, kind of like that snapshot, is just a big blob that is going to have some information, including the information that we loaded out of the store. This coordinator is the thing that goes and searches for that stuff. The really nice thing is going to be that we don't have to create any of this when we use core data, because that's what this persistent container is. It sets up where this stuff is going to be saved, it sets up the way we can actually access it, and it sets up the thing that coordinates between all of that. Sunny. Yes. Core data is something that was created like with the first iPhones, that they said we need something like a database on our device. And these are not actually databases, as we'll see in a second, but they let us treat information as if it's in a database. Yeah, they're equivalent things. So they're honestly, core data itself is a little bit deprecated because there are good enough frameworks that you can download something, for example, called Realm, which is a pod that also works on Android. And so you could do what we've been doing with Firebase, where your frameworks on iOS and Android are pretty similar. You use them in pretty similar ways for this thing that is setting up a local database. But core data itself only exists on iOS. Kimball. I would recommend using it for like a small scale app, but I would say even something like that Realm framework is going to use it on some level, so you'll need familiarity, right? So if you use a framework, any framework, to do a specific thing, you probably need to know the concepts behind that framework. If you use a framework to create beautiful table views, you still got to know how to use a table view. Same with this, you need to know how this persistent container works. The nice thing is it's going to be really easy, which is really lucky for us. So by default, when we use core data, it creates this persistent container. that thing, that persistent container, is called core data intro. So it's called the thing that my project is named. That's nice. It did that automatically for us. That name specifically matches whatever is in this file here called core data intro.xcdata model D. Okay. So that name of the thing we created in the app delegate matches exactly to this thing right here, which is where we're going to set up our classes. It's where we're going to set up our objects. Those names must match because behind the scenes, it's just going to find all that definition for those objects for you. So there's this lazy var. And then it also adds for us this thing called save context. So it goes and it looks at the persistent container and it looks at the context. And there's some function on it called, or sorry, there's property on any context called has changes. And if you have changes, it tries to save it. Where does it save it? The persistent store. How does that work? You don't have to worry about it. How does this has changes work? You should probably know a little bit about. When you have a manage object context, the really shorthand here is once you create a persistent container, it loads everything out of that store into your managed object context. So everything that's saved, all the stuff that's persisted, rather than you going and calling from some plist file and saying, load out this data, it's all present right when you create that persistent container. So, yeah. And that's important because there are pretty big issues with having all your data loaded at once. With Firebase, we don't load all our data at once. Instead, we make requests for that data. When we were saving stuff to plist, same thing. We were making specific requests. Really what those were loading a file for data. But with core data, it's all loaded at once, which means if you're saving a bunch of things at once, you could mess up the data. So think about like concurrency. You know how we dispatch things to certain queues? There's an issue with concurrency because everything in my managed object context could be changed at any point, and all the information is loaded there. So anything I change, if that stuff happens out of sync, then I could mess up what's actually saved. If I create a post, create another post, create a comment on that second post, and then delete that second post, I might not actually get the sequencing of events I wanted there. It's called a race condition. When you need things to be sequenced, but they might not actually sequence. When you need things to happen in a certain order, but because they're firing so rapidly, because there are so many changes, there's no guarantee that those changes are going to happen in the right order. This is an interview term, know it. Should we get an official definition for it? Yes. Cool. Let's all read it together. There are going to be a bunch of interview questions in today's lesson, which is why we're doing it. But in the real world, it's an undesirable situation that occurs when a device or system attempts to perform two or more operations at the same time, but because of the nature of the device or system, they must be done in the proper sequence to be done correctly. When you're doing a whole bunch of operations, they need to happen in an order. Even asynchronous requests happen in an order. A simple example of a race condition, this is great. There's a light switch in some homes. Come on. There are multiple light switches connected to a common ceiling light. When these types of circuits are used, the switch position becomes irrelevant. If the light is on, moving either switch from its current position turns the light to off. Similarly, if the light is off, then moving either switch from its current position turns the light off. Imagine if two people tried to turn on the light using two different switches at exactly the same time. It's actually a really good example. If there was a light switch in the back and in the front, and we both said, let's turn this on at the same time, only one of those actions is actually going to turn it on. So my turning the light switch on after Liana has turned it on doesn't do anything. It's an undesirable result of trying to do certain operations in an order that is not matched to what my desired result is. You'll see this a lot with databases and servers. Nice thing about using Firebase is by using the Firebase Firestore setup, they handle pretty much all that race condition issues for us. They timestamp stuff. They say this has to happen after this happens. But we can still run into this with core data. So race condition, note it is. Another interview term, while we still talk trash on core data, is I said all this is loaded. It's loaded into memory. So memory is not where we save things in our projects, but memory is the active computing that we can do on our computers. If I load everything from my persistent store, that means core data is using up a ton of computing power while it's open. Yeah. So if a managed object context is me loading out all of the stuff from my persistent store, then I'm keeping a whole bunch of information in use in the foreground of my app that I probably don't need all at that time. So it's using up a whole bunch of memory, a whole bunch of computing power that whole time. It's going to affect performance. It might affect the capacity of my app. So know here that specifically about core data, but also remember the difference between memory and storage. Storage is putting the data somewhere. Memory is using the cores of your device or your computer to do stuff. Rod, you had a question? Sorry, when we created this thing in Swift, or when does it like get used? Go ahead. Yeah, sure. This persistent container, think of it like a wrapper for this whole process. It creates all these things. We haven't defined anything about what's being stored yet. That's what's going to happen in that file called core data intro xc data model. That's all going to happen there in just a second. But it's important that we know what we've changed about our app when we add core data to it. It adds this lazy var. So with a lazy var, when is that going to get created? When it's needed, yeah. I think that's a good way of putting it. The first time it's referenced, it creates that instance. Otherwise, it doesn't exist. And so now, this is all in our app delegate. So if we do app delegate .persistent container, we'll be looking at the container that holds all of our persistent data and core data. And if we do app delegate.save context, it's going to look for all the changes in this context, which has all of our persistent data loaded, and it's going to try to save that into persistent storage. When would we save that? Well, a classic example, which they add for us, is when the scene enters the background. So it looks for the app delegate, and it says save context. So save any changes to what happened in my managed object context. Right? If you dismiss an app and the app enters the background, you probably want to persist the data that's been changed so that you can load it out next time you use the app. It's the same persistence idea. as using a plist. But hey, now we can control it a little more. Do you want to see how we control it? It's amazing. I promise you. So in this Xcode or XC data model file, we can create the classes that we want to exist. I should probably put on dark mode because this is really hard to see. What are we trying to do? What? Set the what on dark mode? Work. Yeah, thank you. Ooh, I hate that. Okay, so in here, we're creating objects. We're defining objects. These objects are going to be classes. Core data deals only with classes because core data needs to be extensible back to Objective-C. It needs to run on the Objective-C runtime. We can create entities, for example, a thing called a post. Think of this like we just wrote class post and then opening curly bracket. You can add in here an attribute, so think of this like a variable on it. What does a post have on it? Let's say a title. We say the type of that title. There's only a certain preset number of things here. Title's probably a string. That's great. What else is in a post? Body. Body's probably a string. Adam? Yeah, so we are creating a custom type right now. No, it's okay. Please keep asking. Yeah, so we're going to talk about that in just a sec, but the important difference between using core data here and using our like plist persistent stuff is that this section right here lets us set up a relationship on that definition for us. So I've got a post with a body and a title, and then honestly I think I'm good on that right now. But now let's create the comment. So I add another entity. This is just like defining another class. This thing is called a comment. Go and look at it. Comment has, let's just say a body for right now. That body is going to be type string. So we've got a really simple example. What we can do is we can look at how these things are actually related. So I click down here in this editor style, this guy with a block over 2 blocks. Oh, that's as far as it'll zoom, but on the bottom right, if you're clicked into this file, it'll show you those 2 objects. I don't know why it lets me swirl them like this, but it's kind of fun. At all. This is just a visual representation of what we created in that other view. So the entities, no matter what, we create them. If I click on post, it's going to highlight post. Click on comment, it's going to highlight comment. Should be able to see them. Our main goal here is we want to set up the relationship between these things. We can do that from this view, or we could do it from the inline view. And so let's say I'm looking at a post. I'm going to say a post has comments. That's great. All right. So let's think about this. I've got a post. Is there going to be one comment on a post, or are there going to be a bunch of comments on a post? There will be a bunch. So, say that's what comments look like. A post can have a bunch of comments. This, when we're talking about relating objects, or when we're talking about databasing stuff, and this is really the last and probably most important interview thingy we're doing today. From a systems design standpoint, so when someone says, how would you set up your app to handle a post with many comments? You can click on this relationship, and then they ask you to explain what kind of relationship it is. So the explanation here is a post has many comments. This is called a one-to-many relationship. One post has many comments. Phoenix. Let's go take a look. There's no relationship right now. Damn. What's this inverse thing? Well, let's see first. Let me tell you what this thing is for. A comment has a post, and a post has many comments. This is literally setting up a property on this type that we are defining, where if I create a new post, so if I go look in my view controller, the way I can use these core data types is to import core data. Then I can say, let's make a post. Let post equal post. Come on, buddy. Let's see. Build this guy out. You're not going to work. Let's index this. But what we're defining in here, again, it's classes. I'm literally defining a post as having a body, which is a string, a title, string, and comments. Which, if it was a 2-1 relationship, it would just be one comment. But because it's a to-many relationship, posts comments is as many comments as we say are in that post. See if we can get it to load. Let post equal post. Nope. All right, give me a sec. My notes. Notes, where you at? Sorry, everyone. It's going to be one specific thing we have to do, and then it's kind of done after that, to be honest. So let's just take a look. Going back to what we talked about last week, this is all about configuration. I'm not really writing much code, I just have to use it in the right way. And right now I'm not using it in the right way. Let's figure out what I did. Definitely have to import core data. And then if I want to use that view controller, it is extremely warm in here. Did this multiple times. Post equal, post equal. Okay, great. Let's do some Googling. Core data, how to use need to have the inverse. All right, let's try it out. Cool. Some comments. This guy. Yeah, that's fine. So these two separate sections are attribute and relationship, just the visual layout. Let's just create an instance of this before we go looking too far though. I'd love to create a post. It doesn't want me to though. Great. Creating a managed object. Interesting. No, this is not what I was reading this morning and yesterday. Let's see. Someone creates a post, or their version of a post, just an object called employee. Employee has a relationship to department. Great. Now you have your entity. You can define it further. Great. Aha. There we go. Let's go back and look over here. If I click on comment, I go to the right side. If I hit this class definition, it's going to create the class definition for this thing. Let's see if I can get it to load now. But hold on, before we go very far, on each entity, this code gen thing has to be selected for a class definition. I've had it before. I just want to make sure I'm using it right. Going to what Sunny said, I added relationships for a post and for a comment, in which I can say a post has comments, and also a comment can refer to the post that it is a member of the comments of. So comment, I'm actually going to know got a body, got a post. That post is a specific instance. And by setting up that inverse relationship, which I didn't want to do just yet, it knows it's referring to the specific post that it is a member of the comments of. So this is a one-to-many relationship in which the one post can have many comments. Comment can only belong to one post. And core data does us a favor and says, if a post has a comment in it, if we talk about that comment, we can refer back to that post without setting up those properties. It's great. It's pretty easy. Now let's just make core data work. Yes? No, that's actually a really important point, is this relationship is inferred by us setting up keys on different objects. So here in core data, we say that a post has many comments, and it's defined in this way. But when we're using Firestore, we've got post, really important point. This is called a relational model. And this is called a key value lookup. The definition for the post coming from Firebase versus the post coming from core data or another relational model is that a post is going to have a title, a body, and an ID, and that ID needs to go onto that comment. But for a key value lookup or a NoSQL database or anything like that, there aren't comments inside of the definition of the post. So these are separate. There's no explicit relationship, except that when we look at comments, we know how to find the post that they exist on. If we have the post ID, we know how to get its comments. That's good. Yes, great point. So the double arrow versus the single arrow. So a post has many comments. Comment belongs to one post. And just visually the way they lay that out is a comment has one post, one arrow. A post has many comments, double arrow. Sunny. Yep. Yeah. So this is kind of like a graphical interface for what could be a SQL database. So you'll often see, or you would have often seen, core data, this relationship, was then saved into like a SQLite database, which is relational. So rather than having some persistent store where everything needs to be loaded out at once, you could save all the stuff in your managed object context into a SQLite database and not have to immediately load it, like we've seen with this context, whenever it's used. It's just a better way of structuring that data if your data got too big. But it's kind of not super important for us. You could have used other relational models like MySQL. These are all data types that use a relational model setup. An SQL setup is really what people would just call it, versus what we've seen with Firebase, where there doesn't need to be any relationship. Guys, we're doing it. It's great. But yes, this resembles SQL because the intent was that you use this to abstract out a layer of like information you used during the runtime of the app, so all the stuff that's loaded into memory. And then, if you really needed to, when you go to save stuff, you would save it into a SQL database so that it's not just in some iOS store, but instead it's in a like searchable, accessible database that you could set up specific queries for. I think we had Levi and then Sam.
Super explicit up. When we encoded the JSON object and I took the property, which was of type array, type, but there was only ever one thing in the array. That's because it's a one-to-many relationship. And it's probably a one-to-many relationship to account for the possibility of more than one relationship, even if one doesn't exist.
Yep. Yeah. So our modeling of data, we always want to reflect like the real life object we're talking about as much as possible. So that's why like I didn't write the types of comments or posts there, but the model of a post is something with a title, a body, probably an ID. The model of a comment relates back to that. when you create your models, it shouldn't just be like, what do I need here, but how do I make this thing work if I need to use it in the future in a more advanced way. If you guys remember back to our Unit 2 assessment, no, the Game of Thrones project. There were episodes, there were seasons, and there was a series. And that was just an array of arrays of information. But if you were to model out how a season works, how an episode works, how a series works, those might have other things on them besides a series, which has seasons, and then a season, which has episodes. So going all the way back to Unit 2, when we model out a series, yeah, it has seasons, but it probably has a name, it probably has creators, probably has all this stuff. We're just modeling a real life object. Then with a season, it might have like shooting locations, it might have, I don't know, number of episodes, which is just a computed variable counting the number of episodes in that array. Whenever we create a model, we're just creating something that like makes sense in our heads. That's it. So this model for a post has comments. Comment relates back to a certain post. I know right now you want to be like, how does the magic work? But Sam. Mm-hmm. Yes, a user has many comments. Great question. No, it will not interfere with the relationship to posts. So this will support those relationships for you. A user will be able to have comments, and a post will be able to have comments. And the way it's going to work is, once I get this core data crap working the right way, if you have any user object, you'll just access comments. It'll have everything that was related back to that user. And those can overlap with posts. Posts are, they would be separate objects, yeah. And say you had something called, this is like not especially a core data thing, but you know, say you have multiple contributors on a post. You have a many-to-many relationship between users and posts. So a user has many posts. And this has many thing just really means more than one. If it's ever going to be the case where it needs to be more than one, it's a has many relationship. Post has many, it's called them contributors. So any user that posts is an array post, and any post that contributor is an array of users. It's called a many-to-many. One. One to many. Post. And then this is many. The most you'll hear about that in an interview question is, how would you lay out something like a posting system that has comments on it? You won't have to know how a database actually works. You won't have to write SQL queries for it, but they want to know how you think about the relationship between information. Sunny. let's make it. So I can edit the stuff from right in here. I can go user, and say add attribute down here. Oh, clicked on the wrong thing. Users, attribute, let's say username, and we can click on relationships, and we can say add relationship. That relationship. It's probably going to be easier to edit it in the other view, so let's just do it there. A user is going to have posts, which is a post. There's no inverse right now because it's not set up. Then username is going to be a string. Let's see how that looks right now. Cool. Let's make sure we go back to our users as we add to it, that it has a relationship that is too many with its posts. And now we'll see that there's that double arrow, which means more than one. Let's add some more stuff to posts though. Posts can have comments, which are comments. And that's going to be a too many. So now we see this graph is going to start to grow. And when we add that inverse relationship like we did with post and comment, that's where we saw those arrows back in the other direction. So if I edit post, I can say a post belongs to one user. I'm going to say that relates to its post object. I'm going to call this user. Now we see it adds more arrows here. Tries to lay this out as best as it can. And then a comment can belong to a user, so it can have a one-to-one relationship back to the user. Inverse being that user's comments is the inverse relationship. And if I wanted that many-to-many relationship, what I would set up is, and it won't look much different, but a user has posts, and the post has users. And then I set up too many here as well. Then I see double arrow in both directions if I wanted multiple users on a post. Which just grows and grows, but it's always a line that can be uni or multi-directional, or one or two directions between objects. Yep.
Wait, so when you put in the name thing, will have multiple arrows with
You can do it from either place, but it's easier to edit it as rows. So just click this guy, add relationships to add arrows between the entities, and it's kind of it.
Yeah, when you do the name, I have my relationship.
I don't quite know what you're saying.
Like how you have a double arrow between the user and the post.
All I do to change that is I click on the relationship, and then over here I'll see type, too many, or to one. Yep. And just a note, like this is you defining how these objects are going to be set up. So you could say a user has many posts and a user has many comments, but you might not need the inverse relationship at all. All this would be is any comment.user. If you don't need that, then you don't need it. So think of this still as defining your objects, except core data, when we get it working the right way, is going to do that work for you of defining it. Sunny? What do you mean by binary?
I mean, actually, when we're talking about data structures, we talked about using graphs.
Yes.
So in this case, although it's a SQL database, well, it's not really a database, but it's graph memory, we can also have a graphical way that data is released.
Also the graph array. I would say think of this as just like a really nice editor. It's not setting it up actually graphically for us. These things are still saved in the same way, which is to create tables in a SQL database and then let you go and search for things. But since we're not defining that database, since this is like a layer above it, it's going to do all that work of defining rows and stuff in a very structured way. And all we have to do is get instances and access their properties, whether those are attributes or relationships. I wouldn't think of this as directly relating to like one of those abstract data structures like a tree or a graph. This is just a nice way of laying it out for us. Levi. No. Let's take a 6-minute break so I can make that happen, and then we're good.